Hello friends, today we are going to discuss about chapter 1 of class 9, that is number systems. So first of all, I'm going to introduce what is a number line. So as you can see in this picture, it's a number line. In the center, there is a 0, and towards the positive direction, we have the positive numbers such as 1 by 4, 1 by 2, 1, 2, 3, and towards minus 1 by 3, minus 1, minus 2, minus 3. It represents the negative direction. So you can go either towards the right hand side, that means the positive direction, or you could go towards the left hand side, which is the negative direction. So now we have different types of numbers. First of all is the natural numbers. Natural numbers such as 1, 2, 3, and so on. So these are all the positive numbers. Then we have the whole numbers represented by W. That means all these natural numbers plus 0. So that means natural numbers is a subset of whole numbers W. Then we have the integers represented by Z, that is equal to W plus all the negative numbers, whether it's minus 1, minus 2, minus 75, minus 40, all of these. So as you can see, this girl is asking for YZ and she's having all the numbers including 0. Negative numbers is minus 75, minus 40. Positive numbers as 1, 9, 22, and so on. So there are numbers like 1 by 3, 2 by 4, or even 2000 by 5 divided by minus 2006. The collection of all these rational numbers is represented by Q. So when you talk about all of these numbers, these are referred to as the rational numbers, and collection of all of this is referred to as Q. Now, from where did the word rational came? Rational comes from the word ratio, that means A by B, and Q comes from the word quotient. That is why rational numbers refer to as the ratio as A by B, and Q came from the word quotient, and rational numbers are represented by this word Q. Now we are going to discuss about the rational numbers in detail. So a number R is called a rational number only if it can be written in the form of P by Q. And these both should be integers. That means P should be an integer and Q should be an integer, and Q should not be equal to 0. The rational numbers do not have a unique representation in the form of P by Q. That means they can be solved out into its lowermost level as well. So, wherein P and Q, these should be the integers, this is a compulsory condition, and Q should not be equal to 0. Now we have an example such as 2 by 4 can be represented in the form of 1 by 2, even 10 by 20, 25 by 50, 47 by 94. All of these can be represented in the form of 1 by 2. Hence, all of these are rational numbers. These are referred to as the equivalent rational numbers or the fractions. So we assume that Q is not equal to 0 and that P and Q have no other common factor other than 1. So the meaning is that P and Q both are co-prime. Co-prime means that they do not have any other common factor than 1. So, this is the basic discussion about what are rational numbers, what are equivalent rational numbers or the fractions. So, this is example 1. Are the following statements true or false, and give reasons for your answers. So number 1, every whole number is a natural number. Well, actually it's false because 0 is a whole number but it's not a natural number. So that is why every whole number is not a natural number. Second question, every integer is a rational number. Well, it is true because every integer m can be expressed in the form of m upon 1, wherein the denominator is 1, the numerator is m, and so that is why it is a rational number. Next, every rational number is an integer. Again, it's a false because 3 by 5, this is not an integer but a rational number. Integer has to be only in the form of numerator, and that can be divided by 1 in order to be represented as the rational number. So here we have another question, that is, find 5 rational numbers between 1 and 2. So herein we have the two ways. Number 1, if you have to find out a rational number, that means between a number r and between a number s, so you can add both of them, r plus s, and you can divide that sum by 2. So that gives us r plus s divided by 2, and this will surely lie between r and s. So if you have to find out the number between 1 and 2, add them. 1 plus 2 equal to 3, divided by 2, 3 by 2, that is equal to 1.5. But here we are talking about the rational numbers, so we have to represent it in the form of p by q. So that is a number between 1 and 2. Now you can proceed in this manner to find out more rational numbers between 1 and 2. So these four numbers will be 5 by 4, 11 by 8, 13 by 8, and 7 by 4. So these are the 5 rational numbers between 1 and 2. Now the other solution is that we find all the 5 rational numbers in just one step. We want 5 numbers, so we write 1 and 2 as the rational numbers with denominator 5 plus 1, that is equal to 6. So 1 equal to 6 by 6 and 2 will be equal to 12 by 6, because when you divide 12 by 6 you automatically get 2, and when you divide 6 by 6 you automatically get 1. So we now check whether 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6, do they lie between this range of 6 by 6 and 12 by 6? So yes, these are all the rational numbers between 1 and 2. So the 5 numbers are 7 by 6, 4 by 3, 3 by 2, 5 by 3 and 11 by 6. So we can find that there are infinitely many rational numbers between any two given rational numbers. So this is the conclusion, that between any two given rational numbers there are infinitely many rational numbers. Now, is 0 a rational number? Just think. Can you write it in the form of p by q, wherein p and q are both the integers and q is not equal to 0? So now only we just discussed that a rational number is the one that can be represented in the form of p by q when q should not be equal to 0. So yes, this 0 can be represented in that form as 0 by 1, 0 by 2, 0 by 3, 0 by 4, and all of these will be equal to 0. And this denominator q, it can take any value including any negative integer as well, that can give 0 by minus 4. So that is also a possibility that shows that 0 is a rational number. Find 6 rational numbers between 3 and 4. Now let qi be the rational number between 3 and 4, wherein j is equal to 1, 2, 3, 4, 5, 6. So 6 rational numbers are as follows. So again, what we are doing is we are dividing that. So q1 equal to 3 plus 4 divided by 2. That gives me 7 by 2, and this lies in the range between of 3 and 4. Next is q2. Now what I'm doing this, the previous one the value that I've got is 7 by 2. So this will be added to 3 divided by 2. So this is equal to 13 by 2 divided by 2. That gives me 13 by 4. And this obviously lies in the range and it is lesser than 7 by 2. Next is whatever value is the second one. That means one value was 3 and the other value is 4. So I'll add the same value 7 by 2 to 4 divided by 2 and I get 15 by 2 divided by 2. That means 15 by 4. And so This lies in over here, that is 13 by 4. Again, this is smaller than 7 by 2. The 13 by 4 value is smaller than 7 by 2. Correct? As in the second step. In the third step, we got that 15 by 4. This is greater than 7 by 2 but lesser than 4. In the next step, we add 7 by 2 plus 13 by 4 that we got in the previous step and divide it by 2. And then we get 27 by 8. This will obviously lie between 7 by 2 and 13 by 4. Next we got is 7 by 2 plus 15 by 4 because these are the values that we got using 3 and 4. So we take these and we divide that by 2 and we get 29 by 8. Obviously this will be lesser than 15 by 4 but greater than 7 by 2. And similarly, using any other two values, we have randomly taken 13 by 4 and 27 by 8. Again, add them and divide by 2. We get 53 by 16 and we add an over there, which is lesser than 27 by 8 and greater than 13 by 4. So we have got nearly 6 values between 3 by 4, but we can get infinitely many values between these. So we have got it as 13 by 4, 53 by 16, 27 by 8, 7 by 2, 29 by 8, 15 by 4, and this lies in the range of 3 and 4. Okay, so let's go ahead. Find 5 rational numbers between 3 by 5 and 4 by 5. Now, in the previous example, we did like between 3 and 4, the integers, but here we are talking about the rational numbers itself, that is 3 by 5 and 4 by 5. Now, we have to find 5 rational numbers. So what we do? We multiply the numerator and denominator by 5 plus 1, that is 6. So multiply the numerator by 6, multiplying the denominator by 6, we get 18 by 30. Similarly, 4 by 5, multiplied by 6 by 6, and we get it as 24 by 30. And similarly, using the previous methodology, you find out the 5 rational numbers, or what you can say is just what are the numbers lying between 18 and 24? That is 19, 20, 21, 22, 23. Okay, and the denominator will remain the same, that is 30. So you just divide it, and what you get is the 5 rational numbers that you actually wanted in the question. So let's go ahead. Now state whether the following statements are either true or false and give reasons for your answers. So every natural number is a whole number. Well, it's a correct option. So it's true because the collection of all the natural numbers, including 0, that is referred to as the whole number. Next is every integer is a whole number. Well, it's false because the negative integers, these are not the whole numbers. If you like, there is something called negative, those will be negative, like -5, and that is not a whole number. So that is definitely a wrong statement. Every rational number is a whole number. Well, it's again a false because rational number is like represented in the form of p by q. So if I have like 4 by 5, that is not a whole number. Either only 4 is a whole number, either only 5 is a whole number. So that is p by q, and q does not belong to 0, that we know. But the q should not divide p completely. That will just be a rational number, not a whole number. Next, we are discussing about the irrational numbers. So about this is a number s that is called irrational number if it cannot be written in the form of p by q, wherein p and q are the integers and q is not equal to 0. Simply, if you can write it in the form, it's a rational. If you can't write it, it's an irrational number. So we already know that we have an infinite number of rational numbers between the value of p and q. So it turns out that there are many irrational numbers as well. So examples are, the most famous example is pi. The value of pi 3.141 and infinitely it goes on. And the other examples are root 2, 1.4, root 3, the cube root of 15, and this value is 0.10111011110, and it again goes to an infinite solution. So recall that when we use the symbol, we assume that it is a positive square root of the number. So 4 is equal to 2, wherein when we take out the root of 4, that is plus minus 2. But usually in the beginning of the mathematics that we used to do, we just took the positive value. But positive 2 and negative 2 both are the square roots of 4.